Hi all, so thank you for joining today. Today we're going to be talking about how to simplify your app development process with AWS Step Functions. Presenting today is myself, Ben May. I'm a solutions architect with ClearScale. My background is in systems engineering and management, and at ClearScale I support both the sales team and client projects. So ClearScale is an AWS Premier Consulting partner. We started in Silicon Valley in 2011 and have completed over 900 projects for more than 400 Amazon customers. We have 10 AWS partner competencies, such as data and analytics, migrations, DevOps, and SaaS, and our engineering team holds over 100 AWS certifications. So the agenda for today is how to streamline and simplify the process of building app workflows, how to improve your application resiliency, how to leverage step functions to interface with other AWS services, how to significantly reduce the code you need to write and maintain. And then at the end of the presentation, we'll have a Q&A area. At any time, you can ask questions in the BigMark system, and we will answer those at the end of the presentation. Great, so let's get started. So first things first, what is Lambda? So Lambda is Amazon's function as a service. So this means that you could upload your code, usually a single task, and Lambda takes care of everything required to run and scale your code with high availability. So this is great, but this gets very complicated when an entire application is in Lambda. So some users find problems like my Lambda times out before my code is finished running, since Lambda has a 15-minute maximum timeout. Or they would say, I would like to retry my code if it fails. So if you're running a set of Lambdas and you want to go back if something fails in the future, you want to go back to that original first Lambda and retry your code. It's very difficult to do that. There's a few other things that we'll mention here that we will address in the presentation. So Amazon came out with something called AWS Step Functions to solve some of these problems. So AWS Step Functions is a serverless function orchestrator that makes it easy to sequence AWS Lambda functions and multiple AWS services into business critical applications. So all of this is defined actually within JSON using Amazon's declarative Amazon states language. And how does AWS Step Functions help you? Well, it helps orchestrating long-running tasks, retry and error handling, reduces complex serverless code, improves your application resiliency, and simplifies the integration with other AWS services. So let's go into how to streamline and simplify the process of building app workflows. As mentioned before, Lambda makes it difficult to manage the state and run long-running jobs. So Step Function solves these. With managing state, each step function state receives JSON as input and usually passes JSON as output to the next state. And for long-running code, Step Function integrates with services like Elastic Container Service and Elastic MapReduce, which allows you to run long-running tasks without having to complicate your architecture. So I want to show an example here. This is an oversimplified Lambda workflow of a video processing task. The user is uploading a video. A Lambda is then processing the video and creating multiple qualities for easier streaming. So this Lambda is also creating the thumbnails for this video. It stores those video files in S3, writes the location to DynamoDB, and then emails the customer once the process is complete. The problem here, as I mentioned before, is that Lambda could only run for 15 minutes. So if this is a large video, it could take longer than the 15 minutes to process the video, and then the task never gets completed, and the customer never knows about this. So how do we solve our timeout issues with Lambda? Let's take a look here. Here we've added a container using Amazon's ECS, which is the container service by AWS. We either had to have a container running with code waiting for us to send the video file, or we used Amazon's tools to launch this container and pass the job to it. This will take a little bit of work, but it's not terrible. Once the container has completed its job, it will upload to S3 and send its results to a Lambda that will store the results in DynamoDB and then again email the customer. So this is great. It's looking good, but what happens if something like fails or the video container is busy? We have to keep state somehow in case something goes wrong. So let's add some state in the form of queues. And while we're at it, I'm going to separate the video and thumbnail processing so we could speed up this whole process. Okay, so we've made it. We fixed our timeout issue. We've added some state and we're running the jobs in parallel to speed up things. I'll give you a moment to take a look at what we've done here. So our one simple video processing workflow is starting to become pretty complicated, as you can see. We have a queue for videos that need to be processed and a queue for videos that are finished and need to be stored in DynamoDB and then emailed. So now this is becoming a little bit complicated. What was pretty simple at first is pretty complicated now. You have to manage each one of these parts and you have to manage your failures within it. So now let's look at how to do this with AWS Step Functions. So we run a Lambda with the called start video processing that we have here. We pass the state using step functions to the two containers that will be created by step functions and provided with the required information to run. Once complete, they will both write out to DynamoDB, passing the information directly from the container to DynamoDB using only the step function state language. So here, this is we're running these containers in parallel. They were created completely by step functions. We didn't have to integrate with any other Amazon services. It was created by step functions. And then once we're done, we pass the state directly to DynamoDB using step functions. We did not have to write that code within our container. Once that's complete and we're sure that all of that is written to DynamoDB, then we'll send an email to the customer by triggering an SNS topic, a simple notification service, which will provide the information that will be emailed to the customer. So each one of these boxes are a different state our step functions can be in. For step functions, there's a total of 8 states that your step function can be in. So the first one is a task, like writing to DynamoDB. It's essentially just a single unit of work. We have a choice, so you can make a choice between branches of execution depending on the results of your code. You could have a fail, which stops an execution or marks it as a failure, a succeed, which stops an execution successfully, a pass, which simply passes its input to its output, or injects some fixed data within your pipeline, a wait, which delays for a certain amount of time or until a specified time or date, parallel state, which creates a parallel branch of execution in your state machine. You saw that we had a parallel branch going to our 2 containers. And then map, which dynamically iterates steps with an array of inputs. So you can have a full array of different inputs and then do a different step or a different task based on that input and iterate through your array. Great. So how does that improve your application resiliency? Well, AWS Step Functions has checkpoints and restarts for you to make sure that your application executes in order and as expected. So it has built-in try, catch, retry, and rollback capabilities to deal with errors and exceptions automatically. So you don't have to build this into your actual application code. You could build it into your Amazon state language. Let's take a look at some of these retry handling parameters. So the main one is the error equals. So this allows you to set the type of error, such as timeout, failed task, or permissions issues. Essentially, you can describe different parameters for each type of error you have, such as failed task or a timeout. The parameters that you can describe in those are the interval seconds. So this is the number of seconds before the first retry attempt, max attempts, which represents the maximum number of retry attempts, and the backoff rate. So that's the multiplier, which the retry interval increases during each attempt. So if your interval seconds is 2 seconds and you have backoff rate of 2, the second attempt would be 4 seconds, third 8 seconds, and so on. So if you look at the original Lambda workflow we had the SQS queues coming in, we had the 2 different containers that we had to write, and then we had the queues going out. So it starts to get complicated. You have to write retries within your containers. You have to write retries for each of your Lambdas. You have to make sure that your queues are storing properly and that you're passing state through those queues. With step functions, it's all managed for you. You could simply write your code and then tell it what you would like to do with the error. And then you could also tell it, like, if send email fails, then maybe you want to start the video processing over completely. You don't have to go back and write code to interact with that original start video processing. You just tell send email to go back to that step and it will continue. Great. So how do we leverage step functions to interface with other AWS services? So there are 3 types of integrations. We have the request response integration, which step functions will essentially send it'll send out the task to whatever service you want to integrate with, and it'll wait for an HTTP response, and then it'll progress to the next state or continue to the next state. So if you were doing something like AWS Batch, you would send a job to AWS Batch in your step function. And once AWS Batch got that job, it will say, hey, I started working on it. And then your step would continue to work on, go into the next state. Step functions will not wait for a job to complete, essentially. You have run a job, which the step functions will wait for a request to complete before progressing to the next state. So you would send your request to AWS Batch. It would kick off the job, run that job. Once it's finished, it would respond and say, hey, I'm done, you can continue. And then your step functions would continue and your workflow would keep going. And then lastly, you have wait for callback. So a task might need to wait for a human approval, integrate with third party, or call legacy systems. So for tasks like these, you could pause step functions indefinitely or wait for an external process or workflow to complete. So for example, if you have a user interface where a stock price has changed and you do some sort of recommendation engine on your side, and then you make that recommendation to the user and you said, hey, would you like to buy or sell this stock based on our recommendation? And the user would say yes or no. And if they said yes, it would go down a branch that would say, okay, buy the stock, send an email for confirmation. No would end the process and your pop-up would go away on that user screen. So here's some of the service integration examples. So if you're using Amazon's Elastic Container Service, you could run the container task and wait for it to complete, like we did in our video processing example. If you're using Elastic MapReduce, you could build workflows and execute those directly from step functions. SageMaker could run your machine learning models. AWS Batch could run a batch job and then perform different actions based on the results. And then DynamoDB, you could get, put, update, and delete items directly in your step function. Here's some of the other services that are also integrated with AWS Step Functions. So these services allow you to really have almost endless possibilities with step functions. Using SQS and SNS allows you to kind of connect to many areas within Amazon or within your application. Great, so how to significantly reduce the code you need to write and maintain. So this is an example of a step function. On the right-hand side is the actual output that this JSON has. This is what you see in the console. And when you run the step function, you'll be able to see the task running through these different states. So first we'd start and we'd run a Fargate task. And then depending on the results of that, we would do a notification for a success or a notification for a failure. So here on the left-hand side, you can see our first state is run Fargate task. And what we do is we define a task definition, which is just the code we'd like to run in that task. And then we say, these are the subnets that I would like this task to run in. And it spins up that job and runs the job and closes that for you. So you don't have services or any systems running for longer periods of time than you need. Depending on the result of this, you see there's a states all. We pull that and we could pull in if it is successful or not successful. From here, we would notify our SNS topics and say, hey, this is good. Tell all the subscribers that are subscribed to this topic, or this has failed, and tell those subscribers that are subscribed to the failed topic, and maybe push this into a queue and we can find out why that has failed. So this is only 50 lines of code to run this, but it really simplifies all the error handling and any integrations you'd have to do within your code that would run in Lambda. So how does it reduce the code you need to write and maintain? Well, it removes the complicated state handling and management of multiple services that are required to manage that state. For example, we are using SQS queues to do that, and you can see it gets very complicated in that very simple scenario. It removes the need for writing error handling and retries in multiple places throughout your code. You could reuse your error handling um, and in your step functions in your JSON, and then point it to different areas that you would like based on that decision. You could let step functions pass information to other AWS services and manage the tasks that are running in those services. So now you don't have to run the Amazon SDK or run CloudFormation or anything like that. You just tell step functions, hey, I want to run this and I want to communicate with that service. You know, please do that from here. You could either write into DynamoDB or run Fargate directly in step functions, and it will handle the retries and handle the infrastructure for you. And then all of this really makes it where you could abstract your workflow by letting step functions manage the workflow. So you can add, move, swap, and reorder steps without having to make changes to your business logic. So we showed how to streamline and simplify the process of building app workflows, how to improve your application resiliency, how to leverage step functions to interface with other AWS services, and also how to significantly reduce the code you need to write and maintain. I don't see any questions noted here. So I would thank you for coming. If you have any questions, you can ask me any questions. Just reach out to sales@clearscale.com, and they'll forward anything to me. If you want to do any sort of like sync up calls or have any problems that you're seeing with an Amazon for yourself, let us know and we'll make sure to take care of that for you. Thank you.